Hello everyone. Today we are going to control the direction of these two DC motors with the help of these two push buttons, right? And I will also explain you, in spite of having correct program and wiring, why your motors don't rotate sometimes. So watch this video till the end for better understanding. Now let me quickly show you the pinout of this L298N motor driver. Okay, so starting three pins are for the motor A, which is connected here, and the last three pins are for the motor B, which is connected here. And this pin is for the 12-volt input supply. The middle one is for the ground and this one is for the 5-volt output, right? And the tiny, as you can see on this board, it is a voltage regulator which regulates the voltage from 12-volt to 5-volt. Now you can see on your screens this pin is labeled as in 1, this is in 2, this is in 3 and this is in 4. And all these in pins are used to control the direction or rotation of the DC motor. And it is not predefined that in 1 is used to control clockwise direction or in 2 is used to control anti-clockwise direction. No, it's not the case. You can configure all these pins to control any of the direction. But suppose if you configure the in 1 pin to control the clockwise direction, then you must configure the in 2 pin to control anti-clockwise direction. And similarly for the in 3 and the in 4 pins. Now this starting and the last pin are called the enable pins, also labeled as EN. And these two pins are used to control the rotational speed of the DC motor. Okay. And you may ask why we are having these two extra pins at the back side of these enable pins. So the reason is that these two pins are basically the 5-volt power supply for the motor. Okay. And when we are not connecting these enable A and enable B pins with the Arduino, we need to short these two pins. Okay. And also these two pins using this jumper cap. Okay. This is a jumper cap and we need to place the jumper cap over these two pins. So by placing this jumper cap over these two pins, they get shorted. Okay. So it means that the motor is getting 5-volt power supply for its proper working. And when we do not connect the jumper cap over these two pins, what happens? The enable A and the enable B pins could not get 5-volt supply from these two pins, and that is the reason the motor remains in off state when we do not have the jumper cap present over these two pins, right? And in this project I am not using the enable A and the enable B pins. That is why I need to keep placing this jumper cap over these two pins. Okay, like this. And when we connect the jumper cap over these two pins, the motor runs at high speed. Okay, because the motor is getting full 5 voltage from these two pins, right? Now if you want me to control the speed of this DC motor using these enable pins, comment down below PWM and I will make a separate video on that, because while controlling the speed of this DC motor, we will require a PWM signal for this purpose. Now this is the demonstration showcasing that if you do not place the jumper cap over these two pins or these two pins, the motor won't rotate. So currently I have removed the jumper cap for the motor B, right? So this is motor A and this is motor B. And you will see that the motor B won't rotate when we press the push button, right? Only the motor A is rotating, but the motor B is in stop condition. So that is why the jumper cap is very important for the proper working of this project. Now in this program we are defining push button pins 2 and 3, which are the digital pins, and the direction 1 and direction 2 pins for motor 1 and similarly for the motor 2. Okay. And in the setup function we are defining button 1 and button 2 with the input pull-up mode. Now this input pull-up mode activates something called the internal pull-up resistor inside the Arduino. Okay. And a pull-up resistor makes the pin normally stay at high condition when nothing is pressed. So when the button is not pressed, the pin reads high. Okay. That means button 1 and button 2 will be in high state. And when we press the button, it connects the pin to the ground. So button 1 and button 2 will be in low state. And the direction pin for the motor 1 and motor 2 are defined with the output mode. And initially, the motor 1 and motor 2 are in stop condition. Now you can also use input mode instead of this input pull-up mode, but in that case you would require an external resistor to be connected with the push button. And this is the circuit diagram for that case. Now coming into the loop section, we are reading the digital state of button 1 and button 2, and when the button is pressed, the state of the button is low, right? So B1 is for the button 1 and B2 is for the button 2. Now I have defined three logics here. For the logic 1, if none of the button is pressed, the motors will remain in stop condition. And for the logic 2, if only button 1 is pressed, the motors will rotate in clockwise direction. And similarly for the logic 3, if only button 2 is pressed, both the motors will rotate in anti-clockwise direction. And if both the buttons are pressed simultaneously, we are stopping the motors, okay, which is similar to the first logic. Now these are the functions for the stop motors, clockwise and the anti-clockwise directions. So for the stop motors, obviously all the indirection pin will be in low state. And for the motor 1 clockwise direction, we are writing high signal on the in1 pin and low signal on the in2 pin, right? And for the anti-clockwise direction, we are swapping this logic. It means we are writing low signal on in1 and high signal on the in2. And similarly for the motor too. So if this video helped you understanding the working of this project and the basics of this motor driver, subscribe to my channel for more electronics and robotics tutorials. Thanks for watching this video, and I will see you in the next one.